For today's lesson, our focus standard comes from Grade 8 Geometry, Standard B, Understand and Apply the Pythagorean Theorem. Our topic for this lesson comes from Pythagorean Theorem and the Number System, using the Pythagorean Theorem. Our essential question is, how do we use the Pythagorean Theorem to find missing hypotenuse values? Please take a moment pausing the video if you need to copy down the standard, the topic, and the essential question, along with today's date, set your question column and your note column, and resume the video when you're ready to begin. So I want to start by just reviewing some vocabulary. When we are using the Pythagorean theorem, we're specifically referring to right triangles. So it's really important that we realize that we can only use the formula for Pythagorean theorem on right triangles, which means it can only be used on a triangle with one 90-degree right angle. When we're using the Pythagorean theorem, we have to be able to identify the different sides of the right triangle. When we're talking about the legs of the right triangle, we're talking about the two sides that form the right angle. And in the Pythagorean theorem, these are referred to as sides A and B. Finally, we need to know about the hypotenuse. The hypotenuse is the longest side of a right triangle. It is always opposite of the right angle, and in the Pythagorean theorem, it is used as side C. So if we take a look here at the drawing of a right triangle, you can see it has a 90-degree angle, which we use a square in that corner to show that that is a 90-degree angle. So sides A and B are going to be the two sides that form together that vertex where the 90 degree is found. And directly across from the right angle is the hypotenuse. This is always the longest side, and we refer to it as side C. So we've been talking about the Pythagorean theorem, and it's important that we know that the Pythagorean theorem is a squared plus b squared equals c squared. And that, you might remember the activity where we actually built the squares off of each of the sides of a right triangle and found that if we took the square of each of these two sides, it equals the area of the square formed on the hypotenuse, side C. So that is what this statement is saying. And it is again important that we know that A, B, and C are used on the side lengths of a right triangle only. So with the vocabulary and the formula that we've gone over now, let's go ahead and put this into practice. Here's our first problem, and for each of the three practice problems that we do today, you're going to be asked to find the length of the hypotenuse for each of the right triangles. So in example 1, we have the right triangle, and we're given side A is 3 and side B is 5, and we need to figure out how long is the hypotenuse, how long is side C. So as with any formula that we're going to use, we first want to start by writing out the formula. It's a squared plus b squared equals c squared, and then use the values from the problem to fill in. So if a equals 3 and b equals 5, we're going to fill that in for a and b respectively in our formula. So replacing a with 3, so 3 squared, replacing b with 5, plus 5 squared equals c squared. We're going to be solving for c. So what's the next line going to read? 3 squared is 9. 5 squared is 25, and that equals c squared. So we did the exponents first, always following order of operations in any of our equations. 9 plus 25, think about that for a minute, what are we going to get when we add that together? Should come up with 34. So 34 equals c squared. the area of the square that we could build off of this hypotenuse of the right triangle is going to be 34 squares. We just want to know what is that side length. So we have 34 is equal to c squared. How do we undo what's the inverse operation of squaring a value? And that's what we've been talking about square roots for. So we're going to take the square root of c squared and 34. So it's asking us what number times itself equals 34. I can't think of a number that precisely gives us a whole number. It doesn't seem to be a perfect square. So we're just going to leave it as c equals the square root of 34. We're going to leave it in its radical form since it's not 34 is not a perfect square. We want to think a little bit further though. What is the approximate value of the square root of 34? Well, 6 squared, 6 times 6 is 36, and 5 times 5, 5 squared is 25. 25 is too low, so 5 squared, 25 is too low, and 6 squared is 36, that's too big, and so we know that the value of c is a decimal between 5 and 6, maybe 5 point something, a decimal between 5 and 6. So c is in between the values 5 and 6. Let's try a second example. Here's our second right triangle. Again, you're being given the values for the sides A and B, the two legs of the right triangle, and you're being asked to use the Pythagorean Theorem to find side C, the length of the hypotenuse. Let's go ahead and have you fill in and begin to work through this problem and see if your work matches with the work that I do to find side C. We're going to use example 1 as our format for solving. So first, you plugged in the values for A and B, I would agree. So A was 5, so we would fill in 5 squared. B was 12 plus 12 squared equals C squared. We want to square each of these numbers. Your next line should say 25 plus 144, these are the perfect squares of each of those numbers, equals C squared. We're ready then to add 25 to 144, which should give us 169 is equal to C squared. Again, since we want to undo this square value to find out just what C is, we need to take the square root of both sides. Take the square root of 169 and C squared. What number times itself equals 169? And I will tell you this is a perfect square value, so it will have an exact whole number value. You need to use your multiplication chart that I gave you. That is okay. Well, the square root of 169 is 13, because 13 squared equals 169. So this missing hypotenuse length for C is 13 units. I'd like you to do one more practice problem. For example 3, here is your problem. Again, you're finding the missing hypotenuse length. You're being given the values for A and B, and you're going to plug it into the Pythagorean Theorem and solve for C. Go ahead and pause the video if you need to complete this problem, and then resume the video when you're ready to compare your work with mine. After writing out the formula, the next line you should have would be 15 squared plus 8 squared equals C squared. And then you would want to actual find, use the exponents, find those perfect squares. 15 squared is 225 plus 8 squared, which is 64, and that is still going to be equal to c squared. When you combine 225 with 64, you should get the value 289 is equal to c squared. To undo and find just the value of c, to undo that squaring of the value of c, you need to take the square root of both sides. Again, I'm going to tell you this is a perfect square value. So we take the square root of both sides. The square root of 289 is 17. And 17 equals the value of c. 17 is the length of our hypotenuse right here. So I hope that this video helped you feel a little more comfortable in using the Pythagorean theorem to find the missing hypotenuse lengths of a right triangle. Please make sure your notes are complete and come ready to work more with the Pythagorean theorem in class.